everyone. So this is going to be the last topic for this unit, which is all about dividing polynomials. Now, we once again sort of did this when we talked about the rules of exponents. We talked about how to divide monomials, which if you remember, the way that we do this is that we divide the two coefficients first, like we would normally do, and then we would subtract the exponents with the like bases. So we would subtract the exponents to all the x's, and for all the y's, so on and so on. So a good example is for something like this, 3x to the fifth divided by, 6x to the fifth divided by 3x squared. If we divide the coefficients, it's 6 divided by 3 or 2, and then we subtract those exponents, 5 minus 2, which is 3. So the division of the monomial will look like this. So what I want to do first is I want to do a few practice problems using this. So work on these. Pause video, work on stuff. I'll go over in a second. Okay, so once again, there's no coefficient, so I don't have to worry about that. All I have to do is subtract the exponent. 12, because this is the top number, minus 4 gives me s to the 8th. And for this one, now you could plug this into a calculator, but I want it written still with the exponent. So 3 actually ends up being our base this time, just like the s was over here, because it's the one being raised to the power. So it's 3, 9 minus 5, which is going to be 3 to the 4th. And like I said, you can plug this into the calculator, figure out what it is. I think it's about 81. Alright. Here's the next one. Pause the video, work on stuff, and we'll go over in a second. Alright. So once again, no coefficient, so I don't have to worry about that. But there's an s here and here, and then a t over here and here. So I'm going to do s 12 minus 4 again, and t 8 minus 4. 12 minus 4, 8 minus 4. So this gets me s to the 8th, t to the 4th. All right, over here, now I do have a coefficient. So 36 divided by 4, which, if I plug it into the calculator, should give me 9. And then I have 5 for the a, and 4 for the bottom a, so 5 minus 4. And then for the b, it's 8 up top, so 8 minus 5. So altogether, I'm going to have 9a to the first, because 5 minus 4 is 1, b to the third, a minus 5 is 3. All right. These should be the last two of the review. So pause the video, work and stuff. I'll go over in a second. All right. So once again, we have a coefficient here and here. So 6 divided by 2 is going to give me 3. And then I have a d squared here and a d over here. So d 2 minus 1. So my answer should be 3d. Over here, coefficients 18 and negative 3. So when I divide that and plug it into the calculator, I should end up getting negative 6 as the coefficient. And then for the exponent, 12 minus 3. So altogether, my answer should be negative 6, x to the 9th. All right, so that's pretty much all the practice with the monomials. So the only difference between dividing monomials and dividing a polynomial is that, just like what we did with the multiplication, we're going to actually have to distribute the first term to each part. Now note, when I say dividing polynomials, what we're going to end up having is some sort of polynomial, binomial, trinomial, 3 or 4 parts, and it's always going to be divided by a monomial. We'll see later possibly how to do it with another binomial, but for now, this is the typical example that you'll see. So you'll have something like a two-term polynomial or higher in the numerator, and then a monomial single-term polynomial in the bottom. So I do this. I basically distribute and divide this by 2x, and I'm going to divide this by 2x. So it's going to look something like this. So each term is going to be divided by 2x. And then we do what we just did before. So the 4 divided by 2, well, that gets me 2x 3 minus 1. 8 divided by 2 is 4. X 2 minus 1. And there's still a plus here. So this leaves me with 2x squared for the left term plus 4x for the right term. And then I can simplify in case some x is crossed out, and I end up getting this. Alright, so that's all you have to do with these polynomials. So pause video, work on self, and we'll go over in a second. Alright, so this one's another monomial one. So really quickly, divide those two. 18 divided by negative 3 is negative 6. M to the 1 minus 2 gives me minus 1. N to the 4th minus 2 is n squared. So then this has to be rewritten as negative 6n squared divided by m. Remember, that's what you do when you have these negative exponents. You make it positive and then move it to the denominator. All right. So going back to this one, so here we have a binomial divided by a monomial. So I'm going to rewrite it so it's this divided by 7x squared y squared z cubed, and this divided by 7x squared y squared z cubed. All right. So 21 divided by 7 is 3. 4 minus 2 is 2. 3 minus 2 is 1. Z1 minus 3 is going to end up being negative 2. And then over here, 28 divided by 7 is going to be 4. X squared minus 2 is going to be 0. So I'll just write 0 here. Y squared minus 2 is another 0. And z to the 4th divided by 3, or 4 minus 3 is 1. So x0 and y0 basically drop out to be 1. And this can be moved to the denominator. So altogether, I'll end up having 3x squared y1 over z squared plus 4z. Alright, so this is what my final answer is going to look like. Alright, another question, pause the video, work on itself, and we'll go over in a second. Alright, so again, negative 4a squared, negative 4a squared, negative 4a squared. So 64 divided by negative 4 is negative 16. 12 minus 2 is 10. Alright, so negative 20 divided by negative 4 is going to get me a positive 5, because a negative divided by negative is a positive. And then 3 minus 2 is 1. And then over here, plus 4 divided by negative 4 is negative 1. And 1 minus 2 is negative 1. So altogether, my answer is going to be 16a to the 10th plus 5a minus 1 over a. So that's pretty much how you would rewrite that if you want to get rid of the -1 exponent. Over here, once again, the denominator here is just going to be -3. So divide each one by -3. -15 divided by -3 is just going to be 5. There is no exponent to kind of deal with this, so it's just going to be left as x to the 4th. 21 divided by -3 is -7. And again, nothing to play around with the exponent. And plus 9 divided by -3 is -3. And there we go. And that's pretty much it with the dividing polynomials. Like I said, it's basically taking what we learned about dividing monomials, the quotient rule from before, and just applying it to two-term and higher polynomials. And all it does is just make the process a little bit longer. All right, so here's your exit question. I want you to simplify these two expressions. So you can pause the video, work on it yourself, throw it in the answer. If you have any follow-up questions, please let me know. Otherwise, good luck and have a great day.